Thank you. Thank you. So I'm pretty excited and happy to be here and get the invitation. Thank you. Because this project that I will show you actually starts 2 years ago in the same event. Like was the starting point of the project was during this event after a conversation we had with Rebecca in Oxford when the hotel was burning, right? Yes. It was like we were in an event and the hotel was burning and we were talking about like mapping, literally. So first, like, what is the origin of this effort? So, you know, like in Brazil, land use and land use change are by far the largest source of greenhouse gas emissions, also for biodiversity degradation and so on and so on. But I would just tackle in the greenhouse gas emissions. So if you look at the trends in history, even though we had a deep decline on deforestation, we decreased the amount of emissions we have from land use change and land use. Still today, 70% of our greenhouse gas emissions come from these sectors. Not just like the burning of forests and deforestation, but also from the cattle, from the agricultural activities, and so on. During the years, when trying to face this problem, especially on the land use change, we have developed several systems that can track and monitor deforestation. So some of them very known, like PRODIS, which is like the National Spatial Agency does since '88, monitoring the gross deforestation in the Amazon. Then we have Amazon, which is a non-profit organization that developed another one, which gives information on a monthly basis, SAT, which runs actually on Google Earth Engine today, since 2005. And then we have the third. So we have several systems, but all of them basically are monitoring deforestation, gross deforestation, so the loss of trees. And they are focused mainly basically on the Amazon. There is one system also working for the Atlantic rainforest. What we are missing is all the other transitions. So what happened afterwards? Once you have the deforestation, what happens with this land? It becomes a pasture, agriculture, it's mining. It's coming back into forests or not. So in order to understand really the greenhouse gas emissions, but also the ways to interfere on the land use change, we need to understand all those changes and fluxes. So what we have to do is to move from tree cover change, which is basically what we have today, to land use change. So it's change from a simple matrix like this one, which is basically what we have in those previous systems, which is forest, non-forest, or tree, non-tree, in both ways, and get something more complex like this, which is for every class, you know what's happening between two different periods. This matrix is what you need to do a real good calculation of greenhouse gas emissions. So you have, let's say you have forests in 1 year, and then on the next year you want to know what classes it is. And depending on what transition you have different emission factors for the different parts of the country. So there are some field maps for land use, land cover in Brazil. They were primarily done for the national inventory of greenhouse gas emissions. So we had one for '94, another one for 2002, another one for 2010, which are all made on a traditional way, like with visual interpretation. It's very expensive. So to have an idea, it costs $3 million, involve 90 people working for 14 months to produce 1 year map of Brazil through this method. It's a pretty good result, but it's expensive and complicated. So 3 years ago, we asked to the team that works on these maps in Brazil if they could produce every year this map. So they say, let's say if we have more money or something like that, can you just like produce all the years so we can build up the historical view of what's going on, the land use change in Brazil? And they basically said, well, it's too costly, too complicated, no way we can do it. And actually, there's no like all the capacity to do that on the laboratories that we're working at. So our challenge, and we put to a team of experts on remote sensing, computer scientists, and also specialists on the biomes and land use, was to develop a cheaper, faster, and reliable method to produce this historical annual land cover use maps of Brazil. And in the process, also to create the tools that can facilitate to anyone else, if we can do it, at the end, anyone else could actually replicate what we are trying to do. And obviously publish everything on a web base. So this is a part of a video that is for full on the website that explains how this works.
Meeting in March 2015 in São Paulo, experts in vegetation mapping and remote sensing decided to make a complete map of land use and land cover evolution along the last few decades. Using the traditional methods, the generation of land cover maps based on satellite imagery is very slow, expensive, and dependent on the availability of local equipment and software. The challenge placed on the project was to generate a fast and inexpensive method without any loss of quality. The solution required the use of automatic classifiers and cloud computing. The Brazilian experts signed a technical partnership with Google and started using the Google Earth Engine, a technology with huge capability to process images. This open tool can be run by multiple researchers at the same time and from different places with the same processing power. To cover the Brazilian territory, which encompasses more than 8.5 million square kilometers, 380 images of the Landsat satellite are required. Each of them corresponds to an area of 185 by 185 kilometers. Throughout the year, dozens of images are taken for each site being analyzed. They're made up of millions of pixels, each one representing on average an area of 30 by 30 meters. To get the best resolution without distortion or cloud cover, MapBiomas programmers apply Google Earth Engine tools to clean up and select the best pixels for the desired period. Then, the selected pixels are organized into a mosaic, which represents the ground cover of that region in that period. Each pixel carries almost 30 different attributes, which can be used later in the classification of the land use and land cover. The tasks run in cloud computing. They are broken up into thousands of pieces and processed on servers distributed across the network. This is only the first step. Another major challenge is to classify the images according to the type of coverage or use. Two different methods are used. In order to identify if an image represents native vegetation, water, or urban infrastructure, each pixel goes through a decision tree with parameters established by the MapBiomas analysts for the different regions of the country. In the second method, processing algorithms are trained to identify patterns from a set of samples and determine the probability of a given pixel belonging to the farming, pasture, or planted forest classes. The last production stage involves integrating the mapped classes by applying prevalence rules to generate a single integrated land cover and land use map for the entire country. All the maps produced, as well as the description of the methodology, the processing codes, and the applications created to develop the project, are open and freely available in the MapBiomas webpage. Please access it and check it out.
Okay, so what we did, like we joined a lot of institutions in Brazil with specialties in different areas. So we divide the country in the different biomes. So you have the Amazon, the Cerrados, the Caatinga, the southern fields, and etc. So we have teams working in each of those areas. Not necessarily these are teams that understands about like remote sensing or much about computer science, but they know a lot about those environments and what are the dynamics that really happens in the field. So by mixing this with people that understands about programming, coding, etc., and especially some remote sensing, we could build a team that can work together to actually build up all this process. I'll later on talk a little bit about how we interact actually. So the project has three phases. The phase one, which was like the beta phase, we made a map of 2018 2008 to 2015 with just 6 classes of use, just to kind of learning how this whole thing works and testing the tools, learning how to make the programs and the interface. And then we just launched, like a month ago, the collection 2, which goes from 2000 to 2016. It's 27 classes that we are mapping in total. And we hope by the next year, this time of the year, we will have the full collection from 1985 to 2017. One of the reasons we have to do this on these steps is that we are actually consuming a lot of computing capacity on the way we are working. We are the ones that actually did something wrong. That stopped the whole thing. There is a moment that we thought that we were processing actually one polygon like this, and actually the way we wrote, we were processing the whole planet but the polygon. So it's kind of, but we learned it, so don't do this mistake like us. Anyway, so the main characteristics of this efforts is based on Landsat. We are processing pixel by pixel. We divide the country in small tiles. In each of those tiles, we have specific parameters to make the classification, and it's everything cloud-based processing and everything using Google tools. So it's kind of we use the Google Cloud Storage, we use the Google Computing Engine, Google Earth, and so we're trying to kind of using the whole all the parts that are available. So the first thing we do is like we divide the country in those tiles, which are 1 by 1.5 degrees. So it's like the global index. And each one of those tiles will be worked by the different teams, defining all the steps on the processing. So in a simple way, we first do the mosaic of Landsat image. So you can define by each of those tiles, for example, the period that you want to have the image, how much cloud you want, and et cetera, et cetera. So you compose this mosaic. Then we pass through a series of decision trees, which are the classifiers, to produce the classifications. And so this is a lot of layers. So you have like a layer on forest, and there is another layer which will be like done on just for agriculture, another one for pasture, and so on. So every step of those we save as an asset in Google Earth, which was something really good that we have this year. The first year we didn't have that. So basically, if something goes wrong in any of the steps, we can come back just to the step that we had the problem. So that's the good thing about that. And to have this working on Earth Engine. So we do the classification. Then once we have all the years of each of those layers, let's say for agriculture, pasture, and so on, then we use a temporal filter, which is really extremely important, which is like you put all the images of all the years all together, and pixel by pixel, you try to eliminate the transitions that are not possible. Let's say you have something that says forest, 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 and then non-forest, then next year forest, forest, forest. There's something wrong, right? So you clean up all those things using those temporal filters, save as an asset, and then we go to the integration of all those maps. So it's basically we create a lot of rules of prevalence, who comes first, join all together, and then you have the land cover map. And then comes the last part, which is actually create the matrix of transitions. So we basically select a lot of different a pair of years, let's say 2000, 2016, 2002, 2008, and so on, and compare the maps, and we generate another map, which is like just the transition. So each pixel will say what is the transition that you have there, or if you don't have a transition, and it's saved as also as an asset. This is taking us, if we sum up continuously, this is like 90 days of processing. If you sum up all this, and if we do that right, without taking account all the mistakes that we have along the way. But let's say that's what we have. It will be totally impossible to do it without a tool like this one. So interesting things. That's the type of product that we have available. So one is the mosaic, the Landsat mosaic, and that's something interesting, Rebecca. That's actually people download more the mosaic than actually the maps, which is really interesting because a lot of people working with processing remote sensing in Brazil, the main struggle for them is actually to get the actual image on a quality that they can use. And we have this for the whole country for every year, from 2000 to 2016, the best picture possible using the Landsat. And the way we do this right now is that we save not just the 7 bands of the satellite in each pixel, we also save the fractions and the index. So it's like a total of 28 layers. So it's kind of a superpower mosaic. So it helps a lot for the people that want to work on, like they just want to work with NDVI. That's it. You get, boom, it's done and it's available as an asset on Earth Engine, but also it's possible to download and work on their computers if they want. So we have the map. So this is like a map of Brazil for 2016. Obviously, you can go all the years, fly in the web page. You have the classes here. This is in Portuguese here, but I think it's in English now, in the morning. We just finished to translate this in English. And so in the right side, you will see like what's going on in all the years with the different classes. So you see that actually forest is still going down in Brazil. And you can do this for each. You can see the different classes all separate. For example, this is just like forest, dense forest and open forest, which actually brings this point of the open forest is more like the dry forest. So actually we find more forest than the actual maps of Brazil of forests. So it's using the same kind of a typology and concept that FAO was using. So you can also do this by state. So, I mean, most of the states in Brazil had no idea what they have in terms of land use. So, you kind of walking blindly on defining policies, public policies. And most important, we have like 5,000 municipalities in Brazil, over 5,000 municipalities. And I mean, if the states don't have the data, imagine municipalities in Brazil. So now, I mean, I'm just taking one example of Sinop. It's a municipality that have a lot of change on the last years. So you can, for each municipality, you have there the map. So this is like Sinop. It's a very famous city for agricultural production in Brazil. This is 2000, and this is 2015. So you see, and then you can see here, agriculture is growing a lot. Forest is coming down, and pasture actually is more or less stable, which means that when you look at the data transition year by year, what you will see is that there is not much agriculture turning into forest turning into agriculture, but the forest is turning into pasture and pasture turning into agriculture. So it's kind of one thing moving to the other. So you can see this year by year. You can also go to each of those statistics and see on the tails. You can choose any geography in Brazil and any of the classes, and you will see the whole thing. Download, blah, blah, blah. Yeah, so this one, so what's interesting here is that one of the things that we did is like to put at the same, the Landsat mosaic below the map. So you can actually, by moving this transparency bar, you can actually see the classification over the map. And you can do this for any year. So it's a kind of a way for the people to make this connection of the image and the classification, and you can back and forth and so on. This is another tool. This one is like the tool to actually see the change. So here, what is in green are changes that are like from something that is not like forest or natural vegetation to forest or natural vegetation, and red is the opposite. Then the purple is for plantations, and blue is anything that become water later on. So you can do this in different areas. I just took this one from Rondônia because it's the favorite from Rebecca. It's always talking from Rondônia. But this one is interesting is because you were seeing here, this is the lakes of the new hydropower plants that were built a few years ago. So you can see clearly that's happening. And you can also see that there is actually some growth of forest, but majority of that is just loss of forest in this. This is 2016. So you can basically choose any pair of years, and it's all pre-calculated, so you can actually see the maps for like say, if we want to see just like 2010, 2015, for example, or 2010 to 2012, and things like that. And also you can see this like that, which I think it's very useful to understand what is the transition. So, okay, we don't have, we lose forests, but forests for what? So in this region, specifically, we're actually losing forests to pasture. It's what we are seeing here, right? The big part. But you can see all of them. And if you click in any of those lines, you actually go back to the map and you see what's the transition that you want to see, that you see it on the map. Where are those places where you have this transition? On the next version, we hope to have this for multiple years. So you can actually track this multiple years to see what's going on. Right, Sergeant? And very important, we can actually get to this table. Remember the table that I showed, the matrix that I showed before? So this shows, like, let's say, how much was forest. This is, I think probably Sinop, the municipality that I showed you before. So how much was forest, then now is pasture. Or how much is forest, then it became agriculture. And the other way around also. So based on this, we can actually calculate very accurately the greenhouse gas emissions, what we will do until September this year. So everything is ready for download, so that people can download the collections of maps. They can download the mosaics. We also give the address. If they have account on Google Earth Engine, they can use the asset directly, because the assets are saved there and are public now, and so on and so on. So during the course of doing this exercise, we actually have to create some kind of applications that runs on Earth Engine, but are more user-friendly for people that don't know how to code. I don't know if many of you know that the previous name of code editor was Playground. Imagine Playground for who? So they actually changed the name because I've explained. So we actually create some tools, like the MapBiomas workspace is a space in which you don't need to code, but you can do everything that you need to parameterize the work using that. So these tools are available also to use, as well as the collection of scripts and codes. So we're putting up, hopefully, by the end of the day today. We are just revising some things, but basically all the codes to do all the steps will be available, so you can copy and paste and put on the code editor. There is also a TBD, algorithm theoretical based document, available for each one of the biomes and for the whole project. And also we develop another tool just to collect sampling points for doing the accuracy analysis. This is a collaborative work, so you have all these organizations working on the same platform through code editor and MapBiomas workspace. But institutions are just institutions, right? So what we have is a lot of people. And the way it works is we have some people that are like the brains of thinking what actually we have to find out, what are the strategies we could classify, which are the coordinators of the different areas. So they are like here. Some of them don't code, so they don't go to the code editor, they don't know how to do it. Some of them knows, like Carlos Souza, like Marcos, etc. And there are some people that are actually specialized on coding, so they can actually code and develop the tools in this side. So they are operating in this area on the code editor, and they're basically developing ideas, testing things, and they exchange the scripts through the code editor. We have a kind of a public folder for our group, which all the people can actually go to the same folder and see what's going on today. If they invent something today, the next day the other ones can interact with the script, so it's kind of cool. And then once they do it, then there is a team here, some of them are here, which actually transform everything that it's working here on this workspace platform, where you don't need to know anything about code. It's just like working on the parameters to do it. We will have one session tomorrow that we will explain a lot how this works in details. And so this allows that we have 60 people actually working with Google Earth Engine without knowing one line of code. So I think that the 10,000 that you have there could be easily 100,000, 500,000, because you have people like those people that knows a lot about the environment, knows about what they want to find out, and etc., but they don't know, about coding. So there is several applications that have been implemented since we launched this like a month ago. So we have people working on to create the first deforestation map of the whole Brazil. So there will be like kind of we have deforestation map just for the Amazon. How about if we have a deforestation map for all Brazil, and then we have, how much is the deforestation happening in the whole country? So we will calculate the greenhouse gas emissions. That will be for the end of the year. There is a lot of interesting work done on calculate the productivity of the cattle in Brazil for all the municipalities. So instead of having something that we say, we have one animal per hectare in average in the country, and it's not useful, this information, because it's actually vary from 0.3 to 8 per hectare. So this kind of if you understand where those things are, then you can have specific policies for that. There is an institution from the government working on infectious disease, and they are kind of trying to find patterns to link the deforestation, degradation of the environments, and the spread of those diseases. And so there's, people doing a lot of stuff there. And to end, as we made all the tools available and the scripts and so on, so we are incentivizing other regions to work on the same initiative. So we have one working now at Chaco. So Chaco is another biome. It's a very threatened biome in South America. It's between Bolivia, Paraguay, and Argentina. So there is another group of institutions. So we are not it's not us in Brazil, but it's they have their own institutions. They are just using the same tools and starting to produce the maps for Chaco. And same thing is starting to happen in the other countries that share the Amazon with Brazil. So kind of expanding to them, and then they can work also on the others. So. It's all open, so we invite everyone to try, and everything is available at our webpage and MapBiomas.org. Thank you.
Matt Yedlin from Vancouver. Thank you for an absolutely fantastic presentation and excellent work. I'm really curious how you present these fantastic and significant results to policymakers and government.
That's a good point. So two things. One is we have we first try to ask the government to do it, right? And we think that we want to invite the government also to be part of the effort. But there is a rule in Brazil that says that the government can't work on the cloud. Simple as that. So if you have to process something, etc., you have to do it on your own computers, like INPE do in their own institution and so on. So basically, they couldn't be in the project. Now that actually we have the results and we come to show and say, look, this is what we can do if you're using. So they are actually studying to change the policy so they can be part of the project. But we have in our scientific committee of the project, it's formed basically by people from the different agencies in the government working. So INPE is there is Gilberto Câmara is in our scientific committee. Matt Hansen is in our scientific committee. So we kind of we try to pick up people that will help us to actually make the case that this is really trustful, etc. Now, so before we actually launched the project, the first thing we did was to present this to the Minister of Environment, the Minister of Agriculture, and for the Chief of Staff, like the area of Chief of Staff on the presidency. So just to be sure that they understand and know that this is not Google. This is like us, the Brazilians, the scientists in Brazil, developing what we need for our country based on a technology that's free available from Google. So it's doing good.
Thanks ever so much. I'm Jenny Hewson from Conservation International. We do a lot of capacity building work on reducing emissions from deforestation and degradation. There are a number of other people in this room doing similar capacity building efforts, and I first wanted to absolutely commend you on this. This is, for our community, this is a huge gap that you're starting to fill, which is fantastic. Brazil is always, when it comes to REDD-related work and ultimately GHG inventories, Brazil is always very much at the top, and then there are a slew of other countries in terms of kind of technical capacity. And I was wondering if you could talk for a minute on your experiences with capacity building. You're starting to branch out into other countries. And I was wondering if you could talk a little bit about that. This is absolutely fantastic. Thank you.
Yeah. So we have a lot of Brazilians here. That is a big crowd. So the first line here is everybody that's in the first line here by coincidence. They are working on the project. Mario, which is very close to you, is actually working on helping from GNC, is helping us to build up this network in Chaco. So I would say that took us like 1 week of training in Chaco. So in 1 week of training, Chaco is actually able to do the same thing because they don't have to do the programming and the coding, etc. They just can jump into the map process using the workspace.
And the data's there.
And the data's there, yeah. I mean, all the images are there and etc. So we don't have. And now that we have, actually, you can put the vector information. That will help a lot because we were having to actually build up all the information for the other countries. Fusion tables and et cetera, et cetera. So I think it would be really helpful that it will be totally automatic. Basically, if a new country starts, it's everything there, something like that. So it's be very helpful. So it's kind of, it's not, as I say, this thing is not rocket science. It takes a lot of time to program, et cetera. But once the thing is working, it's basically, yeah, you have to sit down. It's important to have people that really understand the environment because you are doing everything remotely, right? So if there is people that don't understand what happens in the field, they can't, whatever the computer gives back, you accept, right? So it's very important to have people that really understand the thing because they are really picking us and say, well, this is not working. We have to do something different here or something different there, et cetera. So it's, that will be the crucial part.
Please join me once again in giving congratulations to Tasso and finding out the break.